Good afternoon, everyone. Welcome to yet another training in statistics, and I am very sure most of you were in our last training. Thank you for creating time to come and learn more. I want to also thank my colleagues from Forum Secretariat. I want to thank the facilitators, and I also want to thank Professor Rogerio for sponsoring this training. Before we start this training, I would like to allow Professor Rogerio to say a few words before we start. Over to you, Professor.
Good afternoon, everybody. Good afternoon, Foreign Secretariat. Welcome to this proposal writing or to this advanced statistics course. I'm Rogério Chulele, the director of the Center of Excellence in Agri-Food Systems and Nutrition, the center of Eduardo Mondlane University in Mozambique. This course is being offered by the center, but the actual sponsor is the World Bank under the project we call African Centers of Excellence, additional financing. So this set of courses are being offered by the recognition of the importance in training scientists to equip them in order to be able to conduct their research so that they can contribute to agriculture transformation in Africa. That is something that all of us would desire, is the vision that we desire. So that's why we came up with this course, of which this is the third one, and we'll still provide another one, the fourth one, in 2 weeks' time. Given that this funding is from the World Bank, it's important the World Bank will come up to assess to what extent those courses were offered. So I request to all participants so that you fill your email address, your contact. But now I ask for additional information. Let's create a group WhatsApp so that it can facilitate interaction between us and you. Because, for example, in 3 or 4 weeks' time, the World Bank will start assessment of how this course took place, and they'll contact the participants. So let's create a group WhatsApp in addition to the email and the cell phone number that we are providing. With this information that I'm putting here, I would like to invite you, all of you, or to take this opportunity to learn as much as you can, taking advantage of the really well organized, equipped facilitators that we do have, so that we learn and then we get advantage of it. With these words, I would like to declare this course, Advanced Statistics and Experimental Design, opened. Thank you very much. Over to you, Dr. Nyoraro.
Thank you so much, Professor, for those remarks. I can see some of the colleagues are saying they were not here before. So for the new ones, please note that you are requested to register yourselves in the registration link, which we are providing, and the training materials will be provided in the link which shall be shared. If you have any problem, please get in touch with us so that we can actually help you in the process of your training. At this moment, I would like to call upon our facilitators to start the training. Professor Susan Balaba, over to you.
Okay. Thank you, Dr. Arinyararo. Thank you, Professor Rogario, for opening the training and giving us another opportunity to share our knowledge with the world. We are so grateful to the World Bank. We are grateful to Forum. We are grateful to Professor Rogario for funding this training. We are going to do a follow-up, and we are not going to go back to the introductory part of R, but we encourage participants to go to YouTube and download the videos. They are very clear. The notes are still on the Google link. They have not been deleted, so you can follow through. We are going to start from where we ended so that it can depict the name of the course. The course is Advanced Statistics and Experimental Design. So just in case somebody doesn't understand, in your free time, please go through the YouTube and you'll find the recording there. I'll give an opportunity to my colleague, Dr. Helen Namaweje, to introduce herself, and then I'll continue. Helen, go ahead.
Thank you so much, Professor Susan. A lot of thanks to Forum and then the World Bank for the great opportunity they've given us again to share our skills and knowledge to the world. We are always very grateful to the participants. Welcome once again to this learning session. I believe it's going to be interesting and you're going to learn a lot. Keep practicing like we mentioned earlier, and develop a positive attitude towards R. You'll be able to learn a lot of things. Thank you and welcome to the training.
Okay, so we sent out an evaluation form and would like to share the results from the evaluation and also to share with you the objective of the training. So I'm going to share the PowerPoint and it will take a short time. Then I'll give an opportunity to my colleague, Dr. Thomas Odong, to introduce himself and also continue with the training. So let me go ahead and share the training. Okay, so we are going to present something on the evaluation, the results that came out, so that you can know what your fellow participants, the opinions they gave, ways of improving the course. And we hope that whatever you put in the evaluation is already included in what we are going to train so that we can improve the knowledge in statistics. Okay. The ultimate aim of this training is to build research capacity for the next generation of African scientists, specifically to equip them with skills and knowledge in use of R programming language for data management analysis, and presentation of results in a format that would ensure wider dissemination of results and also publication and policy formulation. The specific objectives include that students will learn how to manipulate their data before doing data analysis using interactive commands in R. And also students will learn different efficient techniques in data analysis using R programming. And students will also use the R programming language to analyze data using all inferential statistical tools, such as correlation and regression, categorical data analysis techniques, and generalized linear models. Now, these are results from the evaluation that was conducted 2 weeks before today. Results came from 584 participants. And the question was, what are the challenges? What challenges did they face during the training? And the highest percentage shows that there were some concepts, R concepts, that needed time to grasp. And the other one was power and internet connection. Yes, that is really a problem for all African countries. The internet is a little bit slow, but the Arabs, we believe that when we are training today, we will be visiting those concepts that people did not grasp well. And at the same time, if we don't go through all of them, you can always access these ARA concepts online using the YouTube videos. We also wanted to find out the level of improvement in R programming in the different topics: data manipulation in R, introduction to R programming, downloading and installing R and ARA Studio. So results indicate that under data manipulation in R, 58.06% of the participants indicate that they improved a lot. And then 38.65% say they improved slightly. Very few did not improve. Then when it came to introduction to R, 76% indicate that they improved a lot, and only 1%, approximately 1%, did not improve. Then downloading and installing R and ARA Studio, we find that 85% of the participants indicated that they improved a lot in downloading and installing R and ARA Studio. Approximately 2% did not improve. Okay, so go to the next slide. Then level of improvement in using inbuilt data sets in R, data visualization in R, and exploratory data analysis. And we find that when we come to using inbuilt data sets, those who improved a lot were 55.9%. And then those who improved slightly were very few, approximately 39.33, and those who didn't improve at all were 4%. Then when it comes to data visualization, that is in orange, those who improved a lot were 62.65%, and those who improved slightly were 34.03%, and 3% did not improve. Data exploration, it's in gray. Those who improved a lot is 60.3, and those who improved slightly is 38.3, and those who improved did not improve is 1%, which shows that participants benefited from those topics that are indicated. Level of improvement in correlation, merging data, and updating packages in R. When we look at merging data sets in R, that is in gray, those who improved a lot were approximately 50%. Those who improved slightly were 43%, and those who did not improve were 6%, approximately 7%. Then when it comes to installing and updating packages, those who improved a lot were 75.5%. Those who improved slightly were 21%, and approximately 4% did not improve. Then when it comes to correlation in R, those who improved a lot were approximately 51. Those who improved slightly were 43, and 6% indicate that they didn't improve. Then when we go to level of improvement in R, as far as summarizing qualitative and quantitative variables are concerned, we find that those who improved a lot was 62.6%, slightly were 34%, and those who did not improve is approximately 3%. Descriptive stats in R, approximately 65% improved a lot, 32% slightly, and 3% did not improve. Exploring relationship between two variables, we find that approximately 58% improved greatly, and 37% improved slightly, approximately 5% did not improve. Then the level of improvement in creating R script, saving R script, and cleaning the R console, we find that 73.2% improved a lot, 22.3% improved slightly, and 5% did not improve. Interpretation and reporting data analysis results. Those who improved a lot were 53%, 42% improved slightly, and only 5% did not improve. Then topics they liked most during the training, the largest percentage was data manipulation in R, and then we have exploratory data analysis, correlation analysis, introduction to R programming language, and we also have data visual, also analysis of variance. So these are multiple response. Don't ask me that why is it that the percentage is adding to more than that. One person can have more than 2 or 3 answers. That's why the percentages are like that. Then when we come to, will you be interested in attending a follow-up training if it is organized using R? We found that 100% indicated that they would be interested in a follow-up training. And what topics would you like to see in the incoming training? We found that participants indicated that data analysis and interpretation, has indicated multivariate data analysis. Then we have linear and multiple regression. Another higher percentage is correlation, and also data visualization. Then there's also machine learning and artificial intelligence. R is used in machine learning and artificial intelligence, but we are not going to be covering it this time, probably with time. Then spatial and data mining. We will not also cover spatial and data mining. It also depends on how fast participants grasp the information being passed on. If you understand R and data analysis very fast, then you cover a lot. But improve our programming training. They say more practicals and exercise that will be done. More days of training. That goes to the forum. And then separate participants into their areas of specialization. That is also being planned, and it also depends on funding. Physical training will depend also on funding, and the different universities should contact the forum for their physical training. The facilitators can move depending on what Reform gives them. We also have slow speed during training that will be addressed. My colleagues, Helen and Thomas, please slow speed during training. Make sure you move at least at a reasonable pace. We should always have a speed governor during the training. Okay, next. Please provide your final message to the following. Participants were so grateful for all the support offered by Reform, Center of Excellence in Agri, Food Systems and Nutrition, World Bank, and facilitators during the data analysis training using R programming language. And the percentages you can see, they are approximately 100%. Again, this is a multiple response results. That's why you see that the percentages are going to, if you add up, you'll get something like 200 something. But that is what happens when we have multiple response. Almost all these, including the facilitators, got over 99%. Thank you so much, participants, for appreciating the training, commending the World Bank and Center of Excellence in Agri-Food Systems and Nutrition for funding, commending and also being grateful to the forum for organizing the training. Thank you so much. It is really grateful. In conclusion, participants appreciated the training. Training came at the right time, and it's being offered virtually, indicating that it will cover so many people. They require the training to take longer than 4 hours and also include morning and afternoon. So forum staff, the participants would like the training to start in the morning and also include the afternoon. So I'll leave that to the forum. And also the participant indicated that the course was very relevant and they had learned a lot of applications in R. And the general impression is that participants were happy with the way the course was conducted. They were happy with the interaction with facilitators and use of real examples and case studies based onto their training, enhanced the learning of the participants. Thank you so much. I think that's the end of the presentation. We will share this PowerPoint in the Google link that is going to be established by one of my colleagues, and we will share the Google link again with you in the due course. I'm going to invite my colleague, Dr. Thomas, who is also going to go ahead with the training. Thank you very much for your attention, and thank you for the responses. We are so grateful. Even for this training, please, and you're welcome to participate. Okay, thank you. Thank you very much. Over to you, Dr. Thomas.
Okay. Yeah, thank you very much, everyone. Welcome to our second part of the training. I'm still happy to see 1,000 people registered. We'll try to slow down as much as possible, but we are also going to do a lot more practical along the week. We are going to continue immediately from where we left the other day. So we are continuing with material for day 5 of the other. I'm going to start right from the beginning. just to ensure that it flows smoothly, and then we'll pick up from there. So let me start by sharing my screen. Unless my boss wants me to say something else. So that should be enough introduction for now. Are you guys all seeing my screen? Yes, you have the script that we worked on Friday. That's what we are continuing with. Yeah. So the link will be shared. I think you could share the link for the last link, and then we have. Is everybody seeing my screen? Okay, I see yeses. Okay, great. I also believe that we are not starting from scratch. So we have the same people who were there the other week. Okay, good. Okay, so just to start, let me first remove my video. My face is not very nice to look at, so I don't want to. Okay, so here we have our. So let's start from our ARA. So we have 4 different windows. We have the first window. This is where your ARA scripts are written. Then down below, we have the ARA console. So the ARA console is where you can see your results, but where also you can see the command that you've just run. If there is any error, the error in R always comes in red, but the red does not necessarily mean error. Red can also be a warning. So as we indicated the last time, once you see error, please read the error. Don't get completely, don't stop and get frozen. Read the error and understand what the error is trying to tell you. The other option is okay. So the error you should read the error. Once you've read the error, the easiest way, if you don't have anybody near you, the easiest way to actually get around ARA, especially with error, is you can copy the error and put it in Google, and Google will be able to give out some key things. But as my colleagues indicated, the main sources of error are mainly wrong typing. Sometimes ARA is case sensitive, so you need to ensure if something is capital, should be in capital. If something is small letter, should also be in small letter. So when we are dealing with ARA, we have what we call packages. So packages are a collections of tools that are written by a group of people, or 1 or 2 people, or many people, and that you can use those functions within the package to help you do your data analysis. For you to use the package, the first thing that you need to do, you need to ensure that the package is installed. So if you see line number 1 here, you see line number 1, say install.packages. And then the name of the package should be in the bracket with the double quote. So once you run this line, the package will be installed. The installation of the package only happens once. You don't install the package all the time. Once you install the package, you will not need to install it again. For you to install the package, you need to have the internet. But once you've installed the package, you don't need the internet anymore. So the first line here is to install the package called Agricole. Agricole is a very, very important package for most of agricultural research, data analysis in agriculture. So if you want to run analysis that are related to agriculture, Agricole is one of the main packages. If you are installing a package that is no longer available for the version of ARA that you have, then you need to change the strategy a little bit. We can see here from line 2. So here we are interested in installing this package here, CWHMISC. So the first thing is you need to install what we call DevTools. And then after you install the tool, you need to call the tool, and you use the term library to call the tools. And then you need install.github. So this time is not install.package, but you have install.github. And then you put this into the bracket. Now, sometimes there are different ways of doing this, but always once you fail in one way, then you need to change another way. Okay. So I assume that you have installed all these packages. And if we are going to do the analysis, we are simply going to call the packages, and then we are going to do the analysis. So what I always do, I put the hashtag at the beginning of the line that I don't want to run anymore. So in that case, it can be just like a comment. Okay. Okay. So now, before you do any data analysis, my suggestions are as follows. The first thing that you need to do is to create a folder. A folder is going to be like a room where you have all your tools, and you're going to do all your analysis within that room without going anywhere. So once you open a folder, make sure that in that folder, you have all the data sets that you want to analyze. So the data set, based on what we discussed last week, you can have the data set either as a CSV file, you can have it as a text file, you can have it as an Excel file, you can have it as SPSS, and any other that you have. So once you've created your folder, please put all the tools that you need for your analysis in the folder, and then including the script that you're going to use for the analysis. After that, you need to tell ARA that all the analysis, all the work should be done within this folder. So let's go up and set our working directory. So the working directory is where all your tools and data sets are in. So the easiest way to set a working directory is to go to okay. In recapping ARA? Okay. Okay. Yeah. So let me try to. I thought I was just repeating what was already said the other time. Okay. So the first thing is, if I want to do an analysis, the first thing that I need to do, I need to ensure that I've created a folder. Okay. And in our analysis of today, there was a folder that was shared with you on Friday, the last Friday that we had here. Can I find out from the chat whether everybody has that folder? The folder is for day 5. Can I see in the chat? There are still some few no's. Okay, can you check in the Google Drive for material for day 5? Okay. So the link is going to be shared. Please stop typing no or yes. Now the first thing is we need to the link is going to be posted again, and then you need to download the folder. Okay. So I'm going to give you 2 minutes to download the folder, those who don't have. No, you are in the right place, please. You are in the right place. Yes, you have joined today. It seems today is the continuation of the last time. So please the link, first get the link. The link has been shared. Please get the link and then download all the files in the link. The data that we are going to analyze today is in folder for day 5. So how many people have got the link now? Only those who said no, please. I want to see if there's any improvement. Okay. Yeah. So I want to Edith said you have not yet got, but Edith, you were there last, at least your name appeared among the people who attended last week. So how come you've not got the file? Okay, the link is going to be shared again. Yeah, please, I know you cannot understand what's going on. Just be patient, you're going to understand. Yes, the day 5 material builds into what we are doing this week. So I just want to first wrap it up so that we have kind of a smooth, a smooth kind of transition. I know the course for all sorts of pedagogical, unfortunately, I'm not a teacher, but I'm going to do my best to ensure that everybody gets what we are teaching. Okay, so let's do first thing first. The first thing I want us to do is, yes, day 5 for ARA Studio. So open the link that has been shared and extract that file for day 5. And I want you to copy that folder for day 5 and put it somewhere on your desktop. Okay, so the information for all the training are together in the link that is being shared. So you can start from day 1 up to the last day. Yeah. So we have just been 30 minutes in the training. Please don't get discouraged. We're going to guide you through until the end. So we can start from any point. So what I want is, the first thing is, I want, whether you've just downloaded it, whether you've joined in today or not, I first want you to get the folder. Gilbert, you're not confused. It's okay. We are going to just be patient a little bit. We just want to transition from what we left the other day, so that we can transition a lot more easily. Please share the link, please. The link will be shared shortly. Tamara said my day 5 is not opening. Do you have the folder with you? Okay. Now let's first do first thing first. The first thing that you need to do is do you have the folder? How many people don't have the link yet? I want only people who don't have the link. Can I see the number of people who don't have the link or who have not yet downloaded? You say which link? The link has been shared. Okay, check the link has been put there. Please, if you already downloaded, please don't type anything. I just want those who have not downloaded so that we can follow well. No, you download everything that is in the folder that has been shared with you if you have not done it before. How many people have not yet downloaded, don't have material for day 5? The material. The material is a folder with several things, including a PDF file. Okay, so I'm going to give 2 more minutes for people to have the folder. Kindly share the link. Okay, the link has been shared. Just click on the link and download the files that are in. Okay. Solomon, we are prepared for the training, please. I know you teach statistics, but we are prepared. I mean, we are dealing with different group of people here, so we need to go systematically. Otherwise, we are not going to get anywhere. I mean, if you're already at a different level, just hold on a bit. We're going to get to where you are. Okay. Okay. So I would like you to go inside that folder and check the content of the folder. Let me check what I'm going to show what I have in my folder, and please check whether that is also what you have. Okay, I check in the folder, you should be having the first, you have a PDF, which is analysis of variance. You have 3 CSV files. There's the bone data, there's the newt, and then there is pollinator. And then you have an ARA script, which is t-test and analysis of variance. Can you check whether you have those in your folder? Okay, so those ones who already have them, that's okay. This is for people who have not yet done the, who have not downloaded, those who said they are beginning today. Okay. So I would like you to right click or double click, right click on the last file, which is t-test and analysis of variance.ara. The one that ends with .ara is the last one in the folder. You can open it with ARA Studio. Okay, is that done? Okay, I'm going to go very slow to ensure that for this start, everybody is on board. And after that, we are going to move fast. Whether you're still down, okay, those who don't have ARA or ARA Studio, then you cannot open it. What is ARA Studio? Please, all the material for the first 5 days of the training have been downloaded. I mean, I assume by now you've downloaded them, and I request you to kindly look through that. Okay, so now I'm going to go back and share my screen, the one with the script. And then from there, we can continue. Okay. So you should be seeing my ARA Studio with 4 different sections. I said the first section here is where the scripts is written. For those who are here for the first time, the scripts are the commands that you write in ARA, and these commands are executed, and then you get the analysis. So your scripts, your script will be written here, and then we can run the script from here, and then we get the output in the ARA console. So ARA is what does the work. ARA Studio is a tool that has been developed to facilitate the use of ARA and make the ARA use a lot more simpler. When ARA came for the first time, you will only have the ARA console without the ARA Studio. So the ARA Studio is just a tool that has been developed later to help you utilize or to make the use of ARA a lot more user-friendly. You cannot use ARA Studio without ARA. So your first thing is you need to download ARA, and then download and install ARA. Then you also need to download and install ARA Studio. Then you can use the two together. So here we have where we have the scripts. And here is where the work is done. The ARA itself is here. And then on the upper right-hand side, we have an empty space. This is the environment. Now, in this environment, any object that you create in ARA is going to be shown here. So you can literally monitor all the objects that you created in ARA. And then down here on the lower right hand, you have where there's the graph, the graphics that are shown here. If you're looking for packages, you can also get them on this side. If you're looking for files, you can also get the files this side. So these are the 4 different windows for our ARA Studio. We have where there's the script. We have the ARA console itself, where any analysis that you run is going to be reflected within here. And then we have where there's the object, and then we have where you have your plots and other things. Okay. So are we all at this point? Is what I'm trying to explain clear to everybody? So that we can move. We are going to move slowly. No, the ARA Studio, what you need to do is, we cannot share ARA Studio. You go to Google and type ARA Studio and follow the link, and you will install the ARA Studio. The assumption here is that we are continuing with the same group of people, or at least those who joined today are people who already know ARA, who have used ARA before. But you see, the thing here is that we cannot start teaching ARA now, then we are not going to cover the content that we are supposed to cover now. Okay, good. So you need to install ARA, and ARA, you need to download and install ARA. You need to download and install ARA Studio. Those are the ones that you're going to use for the analysis. Okay. Okay. So now let me come and start briefly once you have ARA, you have ARA Studio. It doesn't matter whether you attended last week or not. You should be able to run and follow what I'm saying now. Okay. Okay. So the first thing here is we start by installing a package. I already explained to you that a package is a group of functions that are developed and can be used for the analysis. So anybody can develop a package and share with colleagues. So the first thing we can do is to run line 1. So I already have ARA Studio. I already have Agricola on my computer, but I'm just going to run it now just to show you what happens. So you can see here down. Okay, so you can see down here that it goes to the website, it said, and then it tells you downloaded 1.2 MB. Okay, so that means there that we have now installed our package Agricola. So the next thing then we need to do is you can then run line number 6. When you see line number 6, if you don't install the package, if you try to run line number 6, which is using the library, you will not be able to get the package. So let's try to run line number 6. So if everything is run without any error, you should be able to see mainly the blue writing, and then you'll have your cursor blinking at the last point there. So the problem is likely going to be installing line, what I have in line number 7. This is likely going to be the problem. Okay, so what you need to do here is you need to first run line 2 and line 3. You run line 2, line 3, and line 4 if you want to install this particular package that is trying to give you a lot of headache. People who already know this, please just bear with me a little bit. Let me try to get everybody on board. Once we reach the right stage, then we can run together. So you first install the dev tools, and then you use the function library to get the dev tools together. Then you can then run line number 4. With that, you should be able to install that package here. So these are the line that is required. These 3 lines. The reason why you're failing to install this package is because it's telling you that this package is not available for the version of ARA that you have. That means it should be for a lower version. But so you can easily use these 3 lines to actually install that particular package. Please, we cannot send emails to 1,000. We cannot send material to 1,000 people. The link is the easiest way to do so. Please just bear with us. The link we'll keep on posting the link here. Yes, ARA Studio literally means run ARA. Okay. So please, can you run the first 3 lines? So it's a lot easier to actually run these commands here without even knowing anything about ARA. As long as you have ARA Studio, you can run these commands and everything will work perfectly. Then we can explain to you what is going on. Okay, somebody is sharing the link for ARA Studio. Please try to get those links and install. So Oliver, have you installed the package DevTools? So you first run line 2, check my line 2. Once you run line 2 successfully, you run line number 3. After that, you should be able to run line number 4. And please, you need the internet. You need the internet to install the different packages. Once you've installed the packages, then you don't need internet anymore. You can use them without the internet. There. So what we are trying to demonstrate with CWH MIS is that sometimes when you're trying to install a package, ARA will tell you that the package that you're trying to install is no longer available for this ARA version. So that means you need to go a longer way. You cannot use just install.package, it will not run. So the first thing that you need to do is that you need this dev tool here that will help you to install that particular line. Okay. So can we then run from line 6? You can run line number 6, that is for Agricole. I already have that. You run Dobby if you already have Dobby. You run Lattice. You run Effects. So once you try to run the library function and it tells you the package is not found, that means you have not installed the package. So you need to go and you need to type the command install.packages and you put that particular function, the name of that function into the double quote. So you can repeat this sentence, this line here, number 2, but in bracket you replace with the name of the package that you want to install. Okay. So can I know the number of people who have failed to run the different commands? Just type the name of the command you failed, the name of the package you failed to get. GTAB is not. Benson. Okay. Can I get somebody to try to show us the error? You can share the Michael Dawood. Can you promote Michael Dawood to share for us the screen? No, please, if what I have is not in the script that you have, please then try to type it there.
Michael should Kadabara, be able to Boniface,
but who is controlling to? I need somebody to allow somebody to share the screen.
We promote Michael.
Yes.
Should we promote Michael?
Yeah, Michael, I'm here.
Okay, you should be able to share the screen now.
Okay.
Doctor, can you stop sharing first and then he shares the screen?
Jolene, can you promote somebody to share the screen? I can stop sharing mine.
We have promoted Michael.
Jolene or
Selma, can you ask him
David?
if he can hear you?
I think they are not hearing me. Let me just
Okay,
walk
Yeah,
there.
if you've installed the package,
me
that's fine. We are going to see what to do with it.
Let me walk there.
Okay, please.
Okay, so Michael, can you show us, you're sharing for us your screen? Okay, you can't. Oh, yeah. No, we cannot hear you. So can you start by running line number 4? No, we're not hearing. Okay. So now you've run line number 4.
That we have here.
But you need the
Number 5, it's okay.
install GitHub.
The problem is on.
So can you
this
go to line
one.
number? You remove the go to line number. Can you modify line number 2?
Yes.
You see line number 2? Michael, can you go to line number 2? Hey, you've got Michael off.
I'm here, I'm back.
Okay.
Yes. So I was saying this one is bringing a warning or an error here that the package is not available for this ARA version.
Yes. So what I'm trying to explain
Yes.
is that you need to modify line number 2. Once you so what you need to type is you need to type install with a dash. Just first, let me share my screen, then and I explain to you what is happening.
Okay.
No, I am. If you want to, please, you have this, you look at my line number 2, number 3, and number 4. If you don't have the command, please type them. So Michael, can you first type line number 3, number 2, number 3, and number 4 the way you see it here? I want, then you can run that for us to see.
Hello, doctor, you are muted. Okay.
So can I, have you typed, Michael, have you typed so that you can share the screen again? I want somebody to type this command and we run and we see where the error is coming from. Okay, so for now, let's leave this package here. And the challenge is once you leave a package without installing, when you go down and you want to run it, then you're going to have a challenge. You're not going to be able to run. Okay, now you at least show us now what, okay. So can you now run your line number 7? Okay, try to run your line number 7. Wait, don't stop it. Okay, so let's wait. You see, when you see the red there, that means it's still installing. Yeah, so you need to be patient until when the stop sign there. So it looks like now you're good to go. Just wait for the compilation to continue.
Yeah. Okay. Yeah, nice, good. Let's try this now.
Okay, so you can see you've successfully installed all that.
Yes.
No, don't run the next. You don't need to run any more of those lines because you already installed the package.
Okay.
Don't run line number 2 anymore.
Okay. Okay.
Okay, you can now stop sharing. I think that is fine now. So let me proceed.
Thank you.
Okay. So the thing here then, that means we need to have all these libraries because we are going to use them. So run all the lines that you have from line 8, 9, 10, 11, 12, 13. Okay. So the next thing that we are going to do now is we are going to do a simple t-test. I first want you to run my line, what I call line 17, and tell me whether it is going to be, whether you're seeing error or not. So can you run line 17? And if you've got an error, please type yes. So if you have got an error, mean you're not set a working directory. Can you copy the error that you have and paste it in the chat? Those who have got error, paste it in this. Yes. So you can see here. Okay, so what we are going to do now is, okay. So all the error that you have is that my data is not found. Okay, so let's do like this to solve that problem. Can you stop typing now? Okay, so let's go to, so let's all go to, can you read up this where there is session? Okay, you go to set working directory, and then you choose a directory. So the first thing you do, you go to session. Under session, you look for set working directory. Under set working directory, you choose a directory. Okay, is that clear to everybody? Why you got an error, for you got error is, the reason is you are trying to call a data set that is not existing in the folder in which you're working. So we need to ensure that we set the correct working directory before we can proceed. So can we go and choose working directory? So for me, I have my working directory on my desktop. I have my day 5 material, and then I click open. Okay, so once you've set your working directory, you can then go and run line 17. You should be able to work without any error. Anybody who has succeeded in setting a working directory and then where is the data? The data is in the folder. I want to see somebody who has not succeeded to tell us. The folder is day 5 folder. Okay, I'm going to repeat the process again. So what we are going to do to set a working directory, the first thing is look up on top of your laptop. There is we have a menu written session. So can you click on the session? So from the session, you're going to see a number of options. You come and select set working directory, and then choose a directory. Remember when I told you the first thing is make sure you download the material. Once you download the material, please ensure that you put the folder that you're going to work on, the folder with the data set, put it somewhere where you can easily access it, and please make sure that it is chosen as a working directory. So with this, you click on this, then you go and search within your computer to find out where your working directory is. So mine is on the desktop. It is day 5. I click on the folder, day 5. I don't click, go inside it. I click and highlight it from out, and then I use the open. So if you cannot, Okiria, can you promote Latif Okiria to share with us the screen? Latif Okiria, please share with us your screen.
Latif, you are promoted. Latif is promoted.
So it's very important that we get the process of setting the directory right. Yeah, and it's also a bit disappointing that after 1 hour, people are still saying, where is the folder? Okay, so Okiria, what you need to do, do you see where where it is written session up there? Take your cursor up, up, a bit up again. There, okay, click on that. Can you come to set working directory down and choose a directory? Okay, click on that. Can you click on the day 5 material? No, don't open inside. Okay, and then click open. Okay, can you now go and run line 16, your line 16? You run the line. Okay. So the problem solved, no? Now the big problem here is you people are not listening to me. Okay, you can now go off. Who else is failing to get the folders on? On Google. Celsa Makanza. Can you promote Celsa Makanza to share for us the screen? No. They don't, they have those ones who don't follow the instructions. So can you promote Celsa to share with us the screen and we see? There is a fee in my word said he can share. You cannot install on your phone, please. ARA cannot work on the phone. The script was shared you are given a link to download the folder with the script in, please. Okay. I'm requesting, who wants to share the screen? Who is having a challenge? One person with a challenge to share the screen?
Kerefe, you are
Yes,
promoted. Please share your screen.
Ogubo. Can you promote Ongubo to share the screen? share the screen. Who's having a challenge? With a challenge to share the screen. Look, Victoria, one time you got the link. You are asking for the link again. Okay, let me just proceed. Okay, we are seeing somebody sharing the screen. Okay. Okay, so before you start, do you see on top of the ARA console, there's something that looks like a broom? Okay, can you click on something that looks like a broom? On top of the ARA console. Move to the right. No. Follow that line and move to the right. There's up there on top, there's something that looks like no. You see where you have your ARA 4.3.1, follow that line until the end. Until the end. No, continue. Continue. Yes, click on that one. Okay, so now you try to run what your, can you run lines? Okay, go to session. Set working directory. Choose a directory. Okay, click on that. So can you look for your ways? No, you go, don't, okay. Okay. Yeah, that is okay. So you can go now and run your line 16.
No, I didn't run
line 16.
No, number 1, number 2, number 3.
No, first run line 16.
Line 16. This one?
Yes.
This one?
Yes.
Okay.
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 Yeah. Now, what is wrong with your line number 3?
Come again?
You're saying you are talking about line number 3. What's wrong with line number?
Yeah. No, I'm saying just I already installed all package,
Okay.
but I didn't run from number 1 actually, number 1 to number 11.
Okay, we can proceed with that now.
Yeah. Just
okay. So from here now, I'm going to move a bit faster now.
Okay. So, should I click on number 1 and install or?
There. Okay. Okay, so once you have your data in, you can check what kind of data you have with you. My line number 18 can show you the first 6 observation. So if you look at line 18, you run line number 18. So you can see from line number 18 that you have 3 different columns. You have column 1, which is on top is written self, and you have the figures down, the 6.3, 1.7, 2. And then cross, you have 9.4, and so on. And then you have mother plan. So here you have, so from here, what you're saying is that from mother plan 1, we have the flower that was cross-pollinated, produce about 6.3, on average 6.3 seeds. The self-pollinated, and then the cross-pollinated one produced 9.4. And then if you go to plan number 2, you go to plan number 3, you go to plan number 4, number 5. So the command head will only give you the first 6 observations. Afirima, your data is, you share your screen. Afirima, can you promote Afirima to share the screen? The last one now, and then we are going to go with people who, because otherwise we are going to spend all 4 hours today just trying to repeat what we did already 3. Yeah, so Benson, the thing here is that you first need to set a working directory. If you don't set a working directory, you cannot get the data in. You cannot install on the phone, please. Okay, so let me talk briefly about this data set, and then we do the analysis, then we go and do we do more analysis. So we are going to build from a t-test, we are going to go and do one-way analysis of variance, and later we're going to progress and move on further. So this is a simple data set that consists of seeds that were collected from different flowers on a plant. So here we look at plant number 1. On plant number 1, there were flowers that were self-pollinated. Okay. Okay, you tell us where the problem is. Did you set your working directory first? Did you set the working directory? Okay, so can you now run your line number 19? So can you? So what is there in your folder for the training? Can you go inside, open that folder, and can you open inside that folder and see whether you have those files inside? So first go inside your folder to ensure that you have that pollinator .csv.
I do, sir.
You have it inside there?
Yes, sir.
Maybe then can you copy that the whole folder and put can you copy the folder and put it on the desktop? Copy the whole folder with the content, put it on the desktop, and start the process of setting the working directory afresh.
Okay. Yeah. I've done that.
Okay, so can you start the session? Okay, click on session. Set working directory.
So,
Go on desktop. No. Okay, go. You choose a directory, okay?
I've done that.
Okay, so where's the file?
This is the file, arrow.
Yes, click, but you look at the content. Your file may not have the content you're looking for. Okay, you try to run it again. Just try to run line 19.
Line 19.
No. For now, let's probably that folder must be empty.
Okay, I'll try it again. Okay, thank you.
Okay. Okay, so let me just finish this now. I think let's first run now. The rest will catch up a bit later. So here we have a data set. In the folder, it is saved as pollination.csv. But now we are calling it in ARA as an ARA object, which we call it my data. So you can see it on this side. This one has 2. So we have from each mother plant, we have data from self-pollinated flowers and data from cross-pollinated flowers. So the idea here is to see whether there's a difference between the cross-pollinated and self-pollinated flowers in terms of seed production. So this is what we call a paired data set, because observation 1 and 2 are all coming from the same mother plant. If you go to these 2 observations, they come from mother plant number 2, mother plant number 3, mother plant number 4, 5, and so on and so forth. Okay. So the next line here, which is line number 20, we are running a t-test. So you can see a small function here, which is said t.test. Now t.test. So here we have the cross-poll. So we are comparing this column here with the self-pollinated, which is the first column. And then here you're saying this is a paired t-test because the 2 points that you're trying to compare are related. They come from the same plant, mother plant. And then with this statement here, alternative equals to 2-sided. That means you're comparing your null hypothesis is just, you're just interested in. Okay, let me try to zoom in a bit. Okay. Okay. So in this case, you are just interested in the 2 sets being different from each other. You're not saying which one is big, which one is higher than the other. You're just saying the 2 are different. So we can run this as a t-test, but this paired t-test because we're saying the 2 pairs that we are trying to compare come from the same plant. So we can run our line number 20. Okay. So I've got an error here. Can anybody explain to us why there is? Can you type in the chat why there's an error? Why you think why I got an error? I got an error because I did not attach. Okay, So the first thing that I'm going to do is I'm going to run my line number 19. With line number 19, I'm telling ARA that when you're looking for this cross-pollinated and self-pollinated, please look in this data set here. So once you attach this, then you don't need to specify where these variables are coming from. So let's first run line number 19. And then we can run line number 20. Okay, so you can see from here that this one tells us that this is paired t-test. The data that we have analyzed, we have compared cross-poll with self-pollinated. And then here we got a T statistics of 15.41 with 19 degrees of freedom. And then with a p-value of 3.4 times 10 to the power negative 12. And the other time we looked at, this is the value that we are going to compare with our p-value. So now let's look at the alternative hypothesis here. So the alternative hypothesis here indicates that the true mean difference is not equal to 0. So here the difference between cross-pollinated and the difference between cross and self-pollinated, with the null hypothesis, the difference between the cross-pollinated and self-pollinated is equal to 0. But the alternative, we are saying the true difference is not equal to 0. And then it goes ahead and gives you the confidence interval for the difference. So the difference between the cross-pollinated and self-pollinated flowers ranges between 2.95 to 3.844, 8867. So what this one is telling us that if you compare, if you get data from 2 flowers from the same plant, you have the plant that within the same plant, there are flowers that are self-pollinated and the one that are cross-pollinated. So here, the cross-pollinated flowers produce more seeds compared to the self-pollinated flower, and the difference will range from 2.95 to 3.88. So the difference is between 3 and 4 seeds. And this is the mean difference, and that mean difference has a range of that. Are we still together? Okay. So we can move a little bit faster now. Now, if, for example, we ignore the fact that we are dealing with paired sample, assuming now that, let me first run the head. Assuming now we don't have information about the mother plant. So we may think this one is coming from another plant and this one is coming from another plant. So in that case, the data set is considered to be unpaired. So in this case, column 1 and column 2 are independent. So let's run line 22, where we ignore. So instead of saying paired equals to true, we said paired equal to false. Okay, so let's run line number 22. Okay, so you can see from here, this is telling us that this is a 2-sample t-test. If we compare to the first one that we had before, the first one was a 1-sample t-test, but this is now a 2-sample. Okay. The T statistics here is 1.99 with 38 degrees of freedom, and then the p-value is 0.05, which is just slightly. Let me try to run the other one and then we can compare. You can see the one for paired. The t-value is 15.4, and then degrees of freedom 19. When we go to the two sample t-tests, you see now we have the t-value is very, very small, but the degrees of freedom is very high. Simply because the degrees of freedom here is 38 because we are considering each data point to be independent of each other. While in the case of the above one, we consider the 20 data points to be related. That's why we only have 19 degrees of freedom, because we have 20 data points that we have there. Okay, so the interpretation for this in this case is, so from here, what we're saying is that there is a significant difference between the number of seeds from cross-pollinated flower compared to self-pollinated flowers, with cross-pollinated flowers on average producing about 3.4 seeds on average. So the interpretation here is that what we look at here, we look at the p-value. Now, this is the p-value that we are going to compare with our alpha. Alpha is the significance level, which is always set at 0.05 or 0.01 or 0.001, depending on the level of confidence that you are interested in. Okay, so now let's proceed so we have finished with running our paired t-test. The best thing, what we need to do now is we need to detach. Remember, we are attached. That means if we continue to do an analysis, it will still be the value that we have here that is going to be in the data set. So let's detach. We run line 23. Okay. So let's read another data set. So this data set is also available in the folder. So you don't need to change the working directory. So let's run line number 26. That. Hey, sorry. I hope it's not the internet. So let's run line 26. Okay. So it is always advisable, once you call a data set, you need to check the data set and ensure that that is the data set you are interested in. So we are going to type down. We are going to type down a small command. Just type it in the console. So I want to check this, my data that I got. Okay. So this is a data set that the measurement was in the length of this animal called newts. So what happened here is that they measure the length of both the male and the female ones. So the first animal that was measured was male. It had a length of 12.31. The second one was also male, and so on and so forth. Maybe we could look for the one that are down. Just hold on a bit. So here we have both male and female animals, and we want to compare their length. we use add to run. We can also use tail to check the last 6 observations. Instead of 8, you add, you can use tail. So here you can see the last ones are female, 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 female. Okay, so what I want us to do now is we want to first draw, we want to draw a simple box plot to look at the length for male and the length for female before we do the analysis to check whether we can actually pick up anything from there. So what we are going to do, we are going to run line number 28. What does line number 28 do? Line number 28 will allow you to plot 4 different graphs on the same page. So this one allows for multiple plots. Per page. Now, if you want to plot six observation per page, you can only change, you can either change this, make it 3, 2, or you can make the 3 there. And this one is going to change whether you are increasing the number of rows or increasing the number of columns. So for now, we want 2 rows and 2 columns. You want 2 rows and 2 columns. So let's run this. Okay. Now I'm going to have a bit of problem with the plotting because I've been zooming all this thing here, so I may have a bit of problem. Okay. So let me first run this command before I go to explain it. So let's run line number 29. Again, the same, I need to attach. The margins are too large. Okay, let me first try to zoom in make it normal, up to size. I'm going to put back the okay. Do you all see my box plots? Okay, how many people got the box plot right? Okay. So now from here, which group has very high, which group has higher variability? Which of the two has the highest variability? The female or male? Okay, I can see male, male, female. Okay, so what we can do, we can look at the length of the box plot. So you can see from here, probably the males have higher variability compared to the female. The females are a bit compact together. The males are a bit widely dispersed. That's what this box plot will tell us. But we can also do a simple, let's just do a simple, and let's say we just type a simple command down in the console, say var, open bracket, my data, and then length. This can give us the variance, but this is the variance of the total data set. So if we want, we need to separate the variance for the male and the variance for the female. Okay. So a box plot will give us a quick. So which animals are longer, the males or the female? Okay, the females are longer. You see the median for the female is around 18 point something, almost 19, while for the male is around 14. Okay, so after we can then run our t-test. Now, in this case, we are not dealing with paired observation because we have male and female and they are not related in any way. So let's run our line number 30. Okay, so on top here, you'll see 2 sample t-tests. Let me try to expand on this. Okay, so you can see it's a 2 sample t-test. The T value is 12.3, 12.5. Degrees of freedom is 58. And the P value is less than 2.2 times 10 to the power negative 16, which is 0.000022. Then, so let's look at the null hypothesis here. The alternative, rather, sorry. So the alternative tells us here that the true difference in means between the female group and the male group is not equal to 0. And given that our p-value is very, very small, that means we are going to reject H0 and we take the alternative. From the alternative, we can therefore conclude that the male and the female have different lengths. And which of them, and you can see the difference in the mean length of the 2 groups has it has a confidence interval of 4.3 to 5.9. Okay, and then it gives you also you see the mean for the female is 19.15, and then for the male is 14.02, and this was similar to what we saw in the box plot. You can see this is similar to what we had in the box plot. Now let's try to change something here a bit. Let's try to change variance.equal and make this false, and we see what will happen. Just modify your line number 30 briefly. Okay. So we can run. Now, when you run, what do you notice? Okay, so here now, when you say the variance in the 2 groups are not the same, then ARA will run for you a different kind of a t-test. it gives you what you call the world two-sample t-test. Now, this is different from what we have in the first place. The first difference to notice here is that when you look at the degrees of freedom here, the degrees of freedom here is 44.08. Now, when we go up, let me run the other one. Okay, let me just run the other one so that we can. So you can see here, the degrees of freedom has decimal place. That means it has been estimated using a certain method. Now let me change to the previous one and run, and then we see you see now from when you run without assuming that the variance are equal, when you assume that the variance are equal, the degrees of freedom is 58.58. But when you don't want to make assumptions that the variance are equal, then the degrees of freedom changes to 44.8. So here you can see the t-value remain the same, but the degrees of freedom will change. And the change of the degree, the more the degrees of freedom, the more confident or the more information you have from your data set. Let me see what kind of questions that we have here. Yeah, so when you're doing analysis, when you're doing a t-test, the normal student t-test assumes that the variance, the variability in the two groups that you're trying to compare are equal. Now, if from our box plot here, we can see that there seems to be more variability among the male compared to the female. Now, so what happens here is then that where there is a lot of variability, we need to take that part of the data with a bit more caution. So instead of having that each of them will give you the degrees of freedom n-1, n-1, we tend to have fewer degrees of freedom for the one with a lot of variability compared to the one with higher variability. That's why we lost the 58. From 58, we went to 44.08. Okay. So we can detach. Okay, now I want to try to run something slightly different here. So in our example number 2, we are starting with, I don't want us to use the any data set. We are going to create our own data set here. So what we are going to do now, we are going to ignore line 38, 39, and 40. We are going to start running line number 43. So line number 43, here, I'm going to create a vector called A. And in A, I will have 3 observations. I have 27, 28, and 30. So let's run line number 43. Yes, because of the variance, you can decide to run a non-parametric, but like we said, there are other t-tests that you can use to do the analysis that is different from the ordinary t-test. The challenge with running non-parametric is then you lose some information. Okay, so we've created A, which we have 3 observations, 28, 29, 27, 28, and 30. Let's see let's summarize A. So you can see the minimum, the maximum. We can calculate the variance of A. We can calculate the standard error of A. Let's also create another vector called B. We can summarize B, calculate the variance for B, calculate the standard error for B. Now, when I reach C here, no, I decided not to have C the way it is, like I added a D to it. Now, C is a special character in R because C is used to create a vector. So when you're creating object, please try to avoid using C as an object. So for me, I use CD instead of C because using C can cause some problems. So always try to avoid using C as an object because C is already something special in R. So let's run line number 53. Get the summary, get the variance, get the standard deviation. We can run 57, 58, 59, 60. Now we don't need this. We are trying to create this object here in in R. Now what we are going to do then, we are going to combine them together. Okay. So what we are going to do now is, remember we created A, we created B, we created CD, and we created D. We want to combine them together so that we can have the first 3 observations will be A, the next 3 observations will be B, C, and then D. So, and we're going to create it, we call it what called a bond time. So here we combine measurements from the different treatments together. So let's first run this. So what I always advise is that once you create something in ARA, please, you need to check what you've created. It's very, very important. So for example, we've created bond time. So what I can do, I can just highlight this part only, and then I run that to tell me, I need to check what I've created. So you can see from here that the first 3 observations, 27, 28, are from A. We had A here. Okay. And then the next 3 are from B. The next 3 are from CD, and then the next are from D. So what I also want to do is I want to create another object which I call treat A, which is for treatment A. And what do I want to do in this case? I use this function rep, and then I said, okay, what you do, create for me character A and repeat it 3 times. So we can run this line here, and then we can check the content. You highlight this, and then you check that. So you can see you have A. Let's create B. You highlight that. You have B. Let's create C. Highlight that. You have C. Oh, I did not create. Oh, I started by highlighting without creating. I need to first create it. I need to create D. Okay. So I've created treat A, treat B, treat C, treat D, And then I also want to combine them together into what I call treatment. So that the first three will be AAA, BBB, CCC, DDD. That will be what. So let's create this. And then we can go ahead and check what we have created. So you can see from here, you have the first three are A's, then you have B's, then you have C's, then you have D's. Okay. Now, what I want to do, remember we first created our bond time, which is this. So what we did, I want to do that the first observation is going to be A. It has a value of 27. The next one is A, value of 28. And then the third one is A, value of 30. Okay. So we are going to combine these two. So the next thing that we are going to do, this is just a simple thing that we're going to run. Please you can always, sorry, I'm being too fast. I can go back. I'm going to repeat the process. Let me just try to run this, then we'll check. Okay. So we are going to create another object, which we are going to call it reps. And then what will rep have? Rep will have 1, 2, 3, but each of them will be replicated 4 times. So let's just run this and we check. I'm going to repeat the process all over again. Okay. So here we have 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. And that's how we created it. So we get this vector here, which is a vector 1, 2, 3, and we repeat it 4 times. Remember, look here, the brackets are very, very important. Once you open a bracket, you need to close it. We open this bracket here, we closed it with the one here. The next one, we open this bracket here, we close it with this one here. Then we open this bracket here, we close it with that. Now, if you don't close the bracket properly, let me first try to remove 1 point there. Okay, you see what happened here now? We have x is telling us there is actually a problem. Say unmatched open bracket. So once we close this, the error should go away. Okay, so just excuse me, let me run this until line 73, then I'll go back and run the whole thing again and explain what is going on. Okay, so let me show you the final product first, and then we can go back and explain what is going on. Okay, so what I'm trying to create a data set in ARA, and in my data set, I have the first column, which I call rep. It indicates the replication. So you can see from here that I have treatment A, first replicate, treatment A, second replicate, treatment A, third replicate. And then I go to treatment B, first replicate, like that. So let me go back and start the process again. For those who may be lost. Okay, so what we are trying to do here, we are trying to create a data set with the 4 treatments, and each treatment replicated 3 times. So in total, that means we have 12 observations. So the first treatment that we are going to create is called treatment A. Now, treatment A has 3 observations in it. That is, the first replicate of treatment A has a value of 27. The second has a value of 28, and then the third has a value of 30. So that is why we are creating A. So A is going to be observation taken from treatment A. So the observation taken from treatment A are 3 observations because there are 3 replications. So line 43, we are simply creating an object called A, and that object A has 3 observations, which is 27, 28, and 30. So we can run that. Okay. Now, we can use the term summary to have to get a kind of a numerical summary for what we have created as A. So let's run line number 44. So number 44 will tell us the minimum observation is 27, which is, yeah, this is what we have as 27. And then the maximum observation is 30. So you can see is 30 here. And then you can tell us the mean for these 3 observations here, which is 28.33. And then the median, then the first quartile, then the third quartile. And these are the information that we use for creating a box plot. Okay, so is line 43 clear to everybody? Anybody who does not understand what we have in line 43, is it clear to everybody? Okay, so we are going to repeat the same thing with B. We are repeating the same thing with C, D, and with, okay. So we have created A, we have created B, we have created C, we have created D. So what we want is we want to bring them together so that they can be in one column. And that is what we have here. So you can see from here, we are creating an object which we call bond time. Bond time will have, the first 3 components will come from A, which we created before. The next one will come from B. The third one will come from CD. And then the fourth one will come from D. Okay, so my command is also clear here. I say combine the measurement from different treatment to have that. So let's run our line number 64. So line 64 will simply get for us the A that we created above, the B that we created above, the CD, and then the D that we created above, and stack them together one after the other. So if we create this, okay, and then I advise you that when you're creating your own data set or doing anything in ARA, you need to check what you've created all the time so that you know, you're sure what you're going to analyze. Otherwise, you may have a big problem. Okay, so you can see from here that the first 3 observations are from A, the next 3 are from B, and then from CD, and then from D. Now, I also want to show that the first observation, the first 3, I want to show that these 3 are AAA. So I'm going to create another object. I call it treat A. So I run that. I run treat B, treat C, treat D. Now, who can tell me why I cannot use summary on treat A? Somebody wants a break time? Let's first answer the question. You get the answer. Answer the question correctly. Joshua, can you answer the question correctly? Then we can have break time. Those ones who did not receive certificate, so I can give you mine. Okay, so they are characters. So you cannot have summaries for characters. It doesn't make any sense. Okay, good. Okay, so let's have a 10 minutes break. I promise you after today, we're going to run. Okay, let's have a 10 minutes break. Up to 4:30. Okay, I think we can start. I'm going to drop for you the commands for installing the other one. You can copy and use it. The challenge here that some people are also here to learn computers, so that makes our work a little bit difficult. Okay, so let's proceed. So one way of getting data in ARA is to create the data in ARA itself, and you can use simple command like what I have here to create the data set. Okay, so we created A, B, C, D, and D. The next one that we created treat A, treat B, treat C, treat D. And then we use line 68 to also combine them. Okay. So here, the first three is going to be A. The next three is going to be B, and then C, and then D. So once we run this line here, that is, okay, so we can then check what we have created. We created something we call treatment. So let's check what it is. You click on that. Okay, so you can see we have A, B, C, and D. And so now we have two columns of our data set. We have the column showing treatment. We have the column showing the measurement from each treatment. The next thing is we need to create a column that shows the replicate. Remember, each of these, there are 3 for each treatment. So we're going to have replicate 1, 2, 3, replicate 1, 2, 3. So here we want to create this pattern, 1, 2, 3, and repeat it 4 times. So this is what this command C actually does. So we can run this line, and then, so you can see here, you have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So now that is done. So we created 3 objects. The first object, we created what called bond time. It has values. The second one, we call it treatment. And then the third one, we call it rep. And then we combine them together into a data set. So here we are going to have the data set that we are going to analyze is going to call bond data. And now we are not using C alone now, we are using C bind. C bind means we are going to put them column by column. They combine them using the column. Okay. You can also have ARA bind, which is a row bind. So what will happen is then that the first column is going to be reps. The second column is going to be treatment. The third column is going to be bond time. Okay, we combine them together like that. Okay, so let's check what we have created. When you're cooking food, you always test whether the salt is enough or not. So now we're going to we created something we call bond data. Let's check what we created. Because sometimes you may want to create something and then it doesn't come out the way you want, okay? So here we have rep 1, 2, 3. For treatment, A. And the bond time for the first rep is 27. For the second rep is 28. For the third rep is 30. Then you go to B, you repeat the same thing. 1, 2, 3. But do you notice one thing here, that Everything seems to be in double quote. What does that mean? Okay, somebody said you have an error on line 68. So Escola, can you share your screen? Can you allow Escola to share the screen? Okay, yeah, they mean they're strings, so they're like characters. So we are going to see yeah, so that's why it is important to actually check your data set, because sometimes you may think you created something, but you created something that is completely different. Okay. Okay, so you're saying you have a problem with line 68. Okay, yours is different. Okay, so let's see. Okay, run that. First clean up the console. Good. So run that line and we see. Yes. So it's saying, okay. Okay, can you start running from your line 347? Run line 347. Can you check it? Check what you have created. No. First check treat A. Just run only the part with treat A to check what is in there. Highlight treat A. No, not the whole thing. Only the part with treat A. That part, yeah, and run. Okay. Can you run the B1? Okay. Okay, can you check? Check what you've created. Okay. Can you run also that one? Somebody seems to notice that you're using, okay, check and, so create, you check. Okay. Can you then create the D and check? Okay. Now try to, try to run that and we see. Can you put a small C? Okay, can you run that now? Okay, so it was because you have a capital C. Okay, you run the treat and you see whether I've got it. Okay, okay, good. So, and you see on top of you have the, do you see the package plot tricks required but is not installed? You see on top there? Check, there is a warning. So you can install. So sometimes what happens is that ARA will read the script and will know that there are some packages that are required, but you've not installed them. So it can warn you and ask you to install them. So it's just good to have that. So you can now stop sharing your screen. Okay. Now I want us to run line number 74. You were introduced to the STR. The STR means you want to know the structure of the data that you've created. Now, this is very important before you do any analysis. Once you get your data in, you need to analyze, you need to understand the structure of it. So let's run line number 74. Okay. So here it will tell us that we have character 1, 2, 3, 1, 2, 3, and then this attribute, and then so this is what it tells us. Now, when we are analyzing data, or in ARA, we have different types of objects or different types of data structure. The first type of data structure that you looked at is the vector. Remember, we created vector A, vector B, vector C. Then the other type is what we call a matrix. A matrix is where you have rows and columns. Now, the third one is what we call a data frame. So a data frame is actually the data set that we mostly analyze. So what we are going to do is we are going to convert the bone structure that we've created. We are going to make it become a data frame. When it becomes a data frame, mean we can now analyze the data frame. So let's run line number 75. Mine is 75, yours can be a different line. Okay, so what we have done here is we have used this function here, data.frame, and then we are converting this into data.frame, but we are calling it the same old name that we have there. Okay, so now let's check whether the structure has changed. Okay, so let's run line number 76. Okay, so you can see from here that now it is a data frame. Okay, and it tells you it has 12 observations of 3 variables. So this is 12 observations of 3 variables. The first column is called rep. It is a character. You see this one, this CHR is character. Then the second column is also character. And then the third column is also character. But remember, these are our observations. These are the ones that we are going to analyze. If they are in character, means we cannot analyze them. So what we are going to do is we are going to convert them into numeric. So when we convert them into numeric, then we should be able to get things like the mean, get things like the variance, and so on and so forth. Are we together? Are we together? Okay, great. Okay. Now, the other thing is also, on the first 2 days, we talked about converting variable into factors. Factors are categorical variables that we can always analyze. So this is not a new command anymore. So what we want to do is we want to have our replicate as a factor. So we're going to use this step here. We said, okay, go to our data set called bone data set, pick the column called rep, okay, and convert it into a factor. This is what it is doing. So it will go to the data set, pick the column called rep, and convert it into factor, and put it back as a factor in your data set. Okay, so we can run line 78. Can run the same thing. We are saying go to the data set, pick the column, what we call treatment, okay, and convert it to a factor and put it back in there. So we're going to run that also. Now, the third column is our measurement, the one that we want to analyze. And it should be in numeric. So we can also force them to be numeric using as.numeric. Up there, we're using as.factor. Here, we're using as.numeric. So let's run line number 8. And then we can check whether the changes that we have made are successful or not. So let's look at the structure again and see what will happen. So we run our line number 81, okay? So you can see from here, it is still a data frame. Then we have rep. Now rep this time is a factor with 3 levels. And the levels are 1, 2, 3. Then we go to treatment. Treatment is also a factor, but it has 4 levels. We have A, B, C, and D. Now, bond time now is numeric. You can see NUM is numeric. So now this is different from what we started with. Now, why I always stress that you need to check what you created, even the data set that you call in, you need to check to ensure that whatever you created is the actual thing. Okay, so let's look at that, what we created. So you can see now all the quotes are gone. So you have your rep 1, 2, and 3 for A, and these are the values that we have. Now, we started our analysis by looking at t-test. A t-test compares 2 groups. Now we have more than 2 groups. We have 4 different groups that we are trying to compare. So a t-test can no longer use. We can use a t-test to make the pairwise comparison, but the pairs may become too many. And then what is going to come in is going to be what we call the multiple, we have an issue with the multiple testing or what do you call it? Multiple comparison. I'm going to talk about that at some point, okay? So we have our data set now ready for the analysis. So let's try to, the first thing that we want to do is we want to do box plot. So the box plot here, now check the box plot here, we have bond time, which is the name of the variable that we want to plot. We want to plot it against the treatment, and the data set that we are using is what we call a bond time. And then we go ahead and we say, please label this as box plot or showing time taken to crush the bonds, okay? So we are going to run this line here. So this is kind of an advanced way of, so let me first. Okay, so you can see from here that we have our treatments here, and then we have the bond time. That's the reading from each treatment. So which treatment, which treatment had the highest time? In the chart, D, okay, which one has the smallest time? Okay, the smallest is B. Which one has the highest amount of variability? Good, so I think we are in business. So we can fly now, starting from tomorrow. Okay. We can also do, we use summary before, but we can do a more advanced kind of summary statistics. So I'm introducing you to a new function called aggregate. So what are we going to do with aggregate? We're saying get your bond time data, aggregate it with treatment, and give me a summary for each treatment. Okay, so that's what say aggregate. So we have the variable that you're interested in summarizing. You want to summarize it by treatment, and then this is your data set, and this is what you want to do to it. Okay, so let's run line number 8 and 9. Okay, so you can see from here that treatment A, the minimum is 27, the lower up, the first quartile, the median. Let me try to run it so that I can occupy a bigger space. I'm going to run, then we can. Okay. So you can see now you have a summary for each treatment separately. You can also only, okay, so in the first case, we are looking at the summary. So the summary will give you the minimum, the first quartile, the median, the mean, the third quartile, and the maximum observation. That's what you get with the summary. But you may only be interested in the variance. So instead of putting the summary, you replace with the variance. So you can see that A has a variance of 2.3, B 6.3, D 2.3, C rather, sorry, and then D is up to 28. And remember, from here, we had indicated that D has the highest amount of variability, and then we seem to see A and C having similar amount of variability. Okay. You can also ask for a standard deviation. So you can also get the standard deviation for each of them. Okay. So you can also do the summary for replicate if you're interested in the different replicates. So we can run this. So you can see, you can run that, you can run that. Okay. So that is our summary statistics. So we moved from t-test, we created a new data set. We checked the data set every time we created it, and then we converted some variables into factors, and some variables, you made them numerical. So it's always important to look at the structure of your data and ensure that you're analyzing the right data. Okay. Yeah, especially when you're dealing with a new package, sometimes you may confuse so many things. So it's important to actually have your data set the right way. Okay. So now I'm really sorry. We are sorry for people who reported today. We've been working on the assumption that we are training the same group. That's why the course was divided into two, so that you can take two parts. Unless or if you are advanced in ARA, you can join at any time during the training. So I'm going to have we are going to make a few suggestions for those who came today. Please ensure that you download all the material for the first training, and go through material for day 1 and day 2 to get yourself acquainted with how to install ARA, how to install ARA Studio, and then from there you can run the commands. It's very easy to run these commands. What you need is you need your data set in the right folder. You need to make that folder to become a working directory, and then you can run the analysis or run whatever command that you have. The biggest challenge is always there errors comes from some typing errors, or you can either have a capital small c instead of capital C, you see what can cause. So today, I think we will stop here. And then tomorrow we're going to pick up from here. And then what we're going to do tomorrow is we're going to run what we call a one-way analysis of variance. We're going to go through a few of these things here. And then we're going to begin to complicate things a little bit and build on to make it more advanced. So we're still going to get the advanced part of it. So I take you back to my boss to take you back to her boss. So over to you, Prof. Susan.
Thank you very much, participants. Thanks for your patience. I also would like to thank Dr. Thomas Odong for taking you through the first day. And for whatever didn't go well, he has already talked about it. Please go download the notes from the link, that same Google link. All the material for the first week, which we trained, is there. So you can download, go through, so that you're ready for tomorrow's session. I would like also to hand over to Dr. Nyararo or any other, or David. David is, I've seen David, he's around. David, I hand over to you.
Yes, Dr. Nyararo is here.
Thank you. Thank you very much for this session. May I hand over to Selma to officially close today? Selma, over to
thank you very much. Thank you very much to the team, Professor Balabas. Thank you so much, Dr. Odong, for taking us throughout the session today. We also want to thank the participant for the active participation. And like what Dr. Odong have said, for those who are coming in for the first time, please visit the Forum Network channel on YouTube and also download the materials. Take yourself through on what people have done a week ago so that you understand where the trainers were starting from. So please catch up, and if you failed to download if you were behind today, please try to go back to the recordings. They are all on YouTube, and we hope that you all filled in your registration for today. So thank you so much. Have a good